we did a few slides in our first chapter, and we have looked at what Android is in general. And so we said last time we said that Android is an open source project, and it's based on Linux. And we said that it is developed by a group of companies. Okay, we're calling Open Handset Alliance and Google. Okay, so and we have said that the number. We also noted that the operating system, which is mobile phone based, there's quite a lot of applications that it can support. Okay. Also, we say that third-party developers can use Android API. For those who don't know what API is, API stands for Application Programming Interface. And what an API does, it's supposed to connect two different programming platforms. Okay. Yeah, the same way if you wanted, for example, to connect, something like Java, to connect it with a database provider like MySQL. Remember, those are two different platforms. So for me to be able to do the connection, I will need an API. Okay, an interface is just a connector. Okay, it's a connection. Okay, yeah. So for you to be able to develop an Android application fully, you'll need to have the knowledge of Java. Yeah. Then we see that Google provides an online market for third-party developers to sell and distribute their custom applications. We all know about that. That is Play Store. Okay, and with I think $25. With $25, you can be able to create an account on Play Store, which is actually a one-time fee. You'll only pay it for life once, and you can be able to publish apps for the rest of your programming life. Yeah, so with only 2,500, you can be able to create a developer account on Play Store. Then we will find that in the notes I shared, there are a number of links I've put there. Okay, those videos are not too long. Like for example, this one is only 2 minutes, so you can take time to look at it so that you can hear from the creators. You can hear from the creators of Android themselves. What are they saying about it? Yeah, I'm quite sure most of you can be able to watch a movie for 2 hours. So these small videos shouldn't be a problem. For 2 minutes also, you just click on the link and watch it on YouTube during your free time. Then we talked about Open Handset Alliance, and we looked at all of these companies. Okay, play a part in coming up with the Android, which we are a part of as developers. There is another video here. It's only 4 minutes. Also, when you're free, try to take some time and listen. And we also said a long time ago you'd need all of these. Okay, you need maybe a music player, portable music player. You'll need a game console. You'd need a pager to send your emails. You'd need a lot of things. But nowadays, you only need your smartphone, and you can be able to do most of the tasks that you could have done with all of these. Okay. Then we also said there was someone who was asking about why did we have to go for Android, and we are trying to compare between Android and the competitors. Okay, so the competitors of Android, we have Apple for iOS, we have Microsoft, we earned Symbian, we earned this is another called WebOS. We also have Research in Motion. Okay, so currently we only have Apple, we have Microsoft, and we have Research in Motion. For Nokia and Palm OS, those ones are no longer being used. Research in Motion, it's a current BlackBerry. It was initially referred to as that. Now it's BlackBerry. Though BlackBerry operating system, I think they only support it up to the end of this year. After this year, BlackBerry operating system will no longer be used. So that means it leaves us with only 2 options. Okay. Actually, even Microsoft, Microsoft are ending their support for mobile phone operating system very soon. Okay, so that means you will not have Windows mobile operating systems. So that means it leaves us with iOS and Android. Okay, so I was trying to access the statistics for the last year, and it shows that in the market, 80% of all the phones are using Android. Okay, so that's a good thing. That's a good reason to target Android, to think of creating Android operating systems. I think last time we checked, only Kate is using, I think, an iPhone, or other people. I don't know. Yeah, so that's worldwide, Kevin. The statistics are worldwide. It shows 80% in the whole world are using Android. Then I would also like us to look at what are the components of your Android, of the Android operating system. Okay, the first component is a Dalvik virtual machine. I've written here soon to be replaced by RT. Actually, it has already been replaced. So that means from Android 5, we are no longer using Dalvik virtual machine. We are using something we call Android Runtime virtual machine, Android Runtime virtual machine, or ART. But I'll explain what that is later. Also, your Android also has something you are calling WebKit. Okay, it has WebKit, and what we mean by WebKit is the browser engine. And browser engine, what that helps you in your Android, it helps you be able to browse web pages. Without WebKit, you could not be able to browse internet or browse web pages on our phone. So this engine or a framework called the WebKit is the one which helps you be able to browse your web pages. We have graphic capabilities, and what we mean graphic capabilities is you can be able to display images, and be able to display images on your phone, both the 2-dimension and 3 dimensions. Okay, nowadays you have phones which have support for 3D images. Then also another component of your Android device is what you're calling SQLite, and this one helps you with the data storage. Then you have media support now for audio and video. Then we have GSM. Okay, so that one allows you to make calls, okay, or send text messages. Then we also have these other wireless connection technologies, such as Bluetooth, Edge, 3G, 4G, near field connection, Wi-Fi. You also have 5G rolling out this year. You have 5G rolling out this year. Then we also, inside your phone, you also have something like camera. We have a GPS for locations. We have a compass to show directions. You have something like accelerometer to measure speed. You have something like a gyroscope for your heart rate. Can be able to. We have devices which can be able to measure your pulse or your heart rate. You have proximity or ambient light. Proximity is for it's able to. We have a sensor that can be able to measure the amount of light. Okay, so that can be able to sense whether it's at night or during the day and such stuff. You have even a barometric pressure, you have fingerprint reader, you have heart rate sensor. I think we also have others with iris scanners. Okay, we have others with what we call radio or maybe infrared. You have one with infrared. Then another component of the Android is software development tools and application framework. Software development tools, they are supposed to help you develop software, so they are embedded in your Android device. Okay, and you'll be able to see that. You'll be able to see that later as we go by. Then now this is the Android software architecture. Okay, we have arranged it into how many layers? We have 1, 2, 3, 4 layers. Okay, so in this case, what I'm referring it, the Android operating system as a whole. It's actually divided into 4 layers, and then you have some little boxes that you can see inside there. I don't know whether it's visible enough. You have some little boxes there, which which show the different components in every layer. In any case, an Android software is composed of 4 layers, but with 5 components, just 4 layers and 5 components. The bottommost layer is Linux kernel, and when we mean it's a bottommost, we means it's the closest to the hardware. And I know you did operating system, and you know what the work of a kernel is. Okay, a kernel is just supposed to provide us with hardware abstraction. Okay, or it's supposed to provide an interface between software and the hardware. Okay, yeah. So for example, in your phone, you have a lot of devices inside there. From what you have seen in the previous screen, you have a Bluetooth adapter. Okay, you have something like a GPS chip. Okay, yeah, you have something like maybe the processor. Okay, let me try to zoom this in. Okay, so what kernel is supposed to do is supposed to give us access to, is supposed to give an interface to the hardware. The same case is supposed to do some low level functions such as memory management. Okay, yeah, so the kernel is in charge of all those. I think you are able to, if you can be able to remember well in your operating system, you know what the kernel is supposed to do the low level services such as low level memory management, linking you to the hardware, such as the audio, that is the speakers, the microphone, supposed to link you to give you a way of accessing those. Then on top there, we have another layer with 2 components, where we have the libraries and the Android runtime. Okay, so the ones you can see in green, these ones, the libraries, they are created using a C or C++. Okay, and they are supposed to help you with high level. They're supposed to give you high level services, high level services. Maybe you can try to look at some of the components we have in libraries. For example, you have the service manager. Okay, so now for the service manager, it's responsible for what you see on your screen, maybe something like the home screen. So that's a library written in C or C++. Okay, yeah. So if you want to develop on this layer, if you want to develop the Android at this layer, you'll need to be very good at C or C++. But most of us, I think, will be going at that layer. In our case, we'll be developing at the uppermost layer there. But you can try to look at it. We have OpenGL or ES, and this one now, it helps us with accessing OpenGL and SGL. They are for graphics, all the images, the drawings that you can be able to do on your phone, the bitmaps and what have you. These 2 libraries or frameworks, these 2 frameworks helps us with that. But remember what we said about frameworks. What the frameworks do is they make your work easier. They make your work easier as a programmer, so that instead of like, even if it's, for example, like an image, instead of doing so much things, okay, because you will find that coming up with a small image, it can involve a lot of code. Okay, so instead of you having to do all that, instead of you going all that hassle, you already have some frameworks that have already been developed for you. The only thing you need to do is just call them. Okay, you just need to call them. So for OpenGL, it's for 3D images, and SGL is for 2D images. Then you have media framework. This media framework now is the one which helps you now be able to include some audio in your application, to play some audio or some video. Okay, so this framework or library is the one which helps us with that. Then we have a free type. We have secure socket layer. That one is for security. You have SQLite for structured database. You have WebKit, and WebKit, I think I have mentioned. WebKit is just for WebKit is a framework for you to be able to browse pages on your on your application. If you want your application to be able to access web pages, you make use you call this framework. You call this framework in your application. This framework we are calling WebKit. Then for Android runtime, the major component here is a Dalvik virtual machine. Okay, but like I said, Dalvik virtual machine has been replaced by Android runtime machine. And what Android runtime machine does is the work is just to execute your application. Okay, because remember, your Android phone, like I said earlier, it has very few resources. Okay, in terms of processor, in terms of maybe something like the memory. Okay, so you find that those resources are limited. Okay, so the Android runtime to make sure that you're able to switch between the different services in your application. Okay, yeah, and what happens is, for example, I think maybe most of you have not done Java, but I can tell you something little about Java. One of the strengths of Java is that once you create an application, it's able to run on any platform. You can be able to run on any platform once you create any program in Java. Okay, so now it's the same aspect we are bringing into Android. And so for Java, for Android, what makes it possible for your application to run on any device, regardless of its hardware architecture, is something we are calling now the Dalvik virtual machine, which has been replaced by ART, Android Runtime Virtual Machine. Then whatever you can see in blue, all the boxes you can see in blue, those ones are created in Java now. And created in Java or Kotlin nowadays. With Kotlin, you can be able to use them. Okay, yeah, and so that takes us to the third layer. The third layer, which is application framework. Okay, so application framework, it also helps us with other libraries, or it makes our work easier by providing most of the services that we'll need to use in our application. Okay, one of the services, it's one we can try to look at some of the boxes inside that layer. For example, you can see here we have a activity manager. Okay, activity manager. And if I can just give you an overview of what an activity is a screen. Any screen that you see on your phone is an activity. Even when your phone is on lock, even when you lock your screen, whatever you see there, that's an activity. When you unlock, that's another activity. For example, when you go to an application like WhatsApp, okay, once you open WhatsApp, the first thing you see is a list of your chats. That's already an activity. When I click on any of the chats, it opens another activity. Okay, when I want to add maybe something, I want to text a new user, it opens another activity. So for you to be able to switch between those screens, or to be able to create those interactive screens, you'll need to call in your application. You'll need to call this framework you're calling activity manager. Okay, then you have another box here which is being called the package manager. Okay, and so what the package manager does, it's supposed to maintain a list of the applications that you have in your Android phone. So it's the one which is responsible for installing a new application and stuff like that. So it's able to maintain a list of what is currently running in your Android application. Okay, and so for you to be able to do that, to be able to create your application, you'll need to invoke the use of the package manager. Okay, yeah, and so that one will bring up something we are calling an APK. I'm sure most of you know it, or the Android application. When you download them from browser, you'll see it ending with an extension .apk. So the package manager is the one which is in charge of that. So when you will be developing your application, there'll be so many files inside there. But then what the user gets is one file. Okay, and so that one is made capable by this framework we are calling the package manager. Then you have the telephony manager. Telephony manager is the one which helps us with creating the dial line or your phone application, the one that you are able to key in the number and make a call. Window Manager is able to, it helps you incorporate use of different windows in your application. So later we'll need to see how we can invoke the use of a window manager anytime we want to create the windows, especially something like home or something. Then we have the resource manager for managing items, for items that are not part of your application. And what I mean by items that are not part of your application are something like strings. You can think of them of something like maybe images, drawings. Okay, all those are resources because they are not part of the code that you write in your application. They're just something that are introduced in your application. Okay, yeah, the strings, the XMLs, bitmaps, yeah, and the images and what have you. Okay, but we'll be seeing as that we'll be looking at that as we go by. Then we have another box here, which is being called content providers. Okay, and content providers helps an application to share data with other applications. For example, if I want to text someone, I can be able to access my contacts. So the contacts application is able to share the details of the contacts with all the other applications on your phone. Okay, yeah. So and that one is for us to be able to achieve that, we'll make use of this framework we are calling content providers. Then we have something like the view system, and the view system is all the components that you're able to interact with on your application. I hope we are all following. I'll ask some questions maybe after this. So view system, it's all the components that you are able to incorporate in your interface. For example, a button. Yeah, you can have something like maybe the layout itself. Okay, the tabular layout, the menu layout, and what have you. That one is made possible. Either it's a text box. That one is made possible by this framework we are calling a view system. We have the location manager for locations, and you have notification. If you want to send notifications to your users, you'll need to invoke this framework we are calling a notification manager. And then the topmost layer now is the applications. Okay, the application, both system apps and user applications. System apps are those apps that which come with your operating system when someone buys a new phone, such as the home, the contacts. Okay, yeah, and they are supposed to do some crucial tasks. Then user applications are the ones that the user installs either from the Play Store or obtaining a package from the browser. Okay, and so that one are available at the topmost layer. Yeah, so in that layer you can have the phone, the browser, and all the applications that you develop yourself. And so that one now sums up our 4 layers of the Android. So that's how Android is organized. So you'll find that each layer will need to interact with the layers below. For example, here at the application, that's where we as developers are. We are in the topmost layer. For us to be able to make it possible, we must interact with the layer. We must be able to interact with the application framework layer. Okay, the application framework layer is able to interact with the libraries. Okay, so remember, you can be able to develop when you want to be part of the Android, you can develop at any of these layers. Okay, the ones who are developing at the topmost layers, those ones are us now, the application developers. The ones who are developing at this application framework, we call them the SDK developers. Okay, those ones are in charge of developing the application frameworks. The ones who are developing at this layer, the one with green, those ones we call them the NDK developers. Okay, so these ones are in charge of developing high-level libraries. And the ones who are developing down here are those who are contributing to making the Linux kernel better. In one with the question concerning the architecture, I know they are it looks like a little bit complex, but if you look at it, it's not that complex. You just need to understand how each layer interacts with the layer below it. So that's why I'm saying, for example, in your case, you must be able to interact with the application framework for your app to work. The application framework must be able to interact with the libraries and the Android runtime. Same case with these ones must be able to interact with the Linux kernel. For example, when you want to access, when you want to send files over Bluetooth and then what have you. Anyone with a question on the Android software architecture? Kennedy, have you understood the architecture, or maybe there is somewhere you don't understand? Kennedy, John, Ian, Winfred, Kevin, with a question on that on software architecture for Android. Just ask questions. If you don't ask questions, I'll feel like I'm the only one in the class. Yeah, so to get maybe an equivalence of what I have explained, you can always go back. There is a video. Yes, John, you want to ask a question?
Does the touch screen use the keyboard driver?
Sorry?
Does the touch screen use the keyboard driver?
The touch screen, does it use a keyboard driver? So for touch screen, it makes use of the graphics driver. It doesn't make use of the keyboard driver, because what basically for the keyboard, that's a virtual keyboard. The ones that you're able to type with, we call it a virtual keyboard. Yeah, so you don't need a keyboard driver because you don't have any. Because remember, the drivers, for those who don't know about drivers, they're supposed to provide instructions on how to work with a certain hardware device. Okay, for example, the keyboard driver is supposed to provide instruction on how to work on a keyboard. So for the keyboards that we use on our smartphone, they are just virtual keyboard. So that one makes use of the graphics or OpenGL, or what you're calling maybe the service manager, probably. Actually, they make use of the service manager, not the graphics or the touch screen. Another question? Remember, for you to be able to successfully develop your application, you'll need to understand the architecture. So if you need to hear from the developers concerning the software architecture, you can always watch this YouTube video, which is only 13 minutes. Kevin, you want to ask something? So on John's question, John was asking whether the touch screen uses the keyboard driver. Okay, but what I said is the touch screen doesn't make use of the keyboard driver. Okay, it only makes use of the graphics driver. The graphics driver is for the whole touch screen. Okay, the graphics driver is for the whole touch screen, and so for the hardware part, it makes use of the, because remember your phone has a graphics chipset, and what we call a graphics card. Your phone has a graphics card, a very small graphics card. So for touchscreen, anything you do on the touchscreen is made possible by the graphics driver. But now for them, virtual keyboard, we make use of a library we are calling the service manager, which is in the second layer from the bottom. Okay, high level, it only means they are supposed to perform advanced features. That's what I mean by high level libraries. Yeah, it's just a library like any other, or it's just a framework like any other, but it's used to perform advanced services, supposed to provide advanced services. For example, libraries here are what we are calling the advanced high-level libraries. But also these ones in the upper layer, in the application framework layer, they are also libraries, but they don't perform advanced features as compared to the ones below it. Okay, yeah. So the higher you go, the cooler it becomes. The lower you go, the more complex it becomes in the layers. Kevin is asking why bytecode cannot run in Android. Actually, they are bytecode. Whatever run in the Android, they are bytecodes. That's why they are able to. That's why your application can be able to run on any device, regardless of the architecture of the processor. Okay, yeah, and you'll find that for the bytecodes, you'll find that with Java, the bytecodes are files with ending with .class. Okay, but the difference between those ones and the ones which run on Android runtime virtual machine, as compared to the ones that run with the one for machines, is they end with .dex extension. So all the Java classes that you create, they are usually converted to .dex. So now the Android, or what you're calling ART, is the one which will execute those .dex files, .dex files. So if you are able to decompress your APK file, you'll find a number of .dex files inside there. And .dex, what simply they are Java classes. They are just Java classes which have been converted to bytecodes. So they are bytecodes. The only difference is that instead of having .class, they have .dex. And I think the reason why they have .dex is because you can't compare an Android phone or a mobile phone with your machine in terms of resources. So John, it's bytecodes, just in different formats. And something I've noted when we were discussing the architecture, we mentioned about Android software development kits. Okay, these are one of the, actually not even architecture, I mean the components of the Android. These are so for you to be able to develop your application, you need an SDK. Yeah, you need to install an SDK. Apart from the IDE, you need an SDK, and the SDK, they make your work easy as a programmer. Okay, they give you all the tools that you need. For example, one of the tools is development tools. Debugger is for removing errors. Okay, monitors are for checking. They are able to check your code that has how it's performing, how your code is performing. You have editors, then you have libraries, maybe for maps. Remember, I said those are libraries are nothing but frameworks that you can call when you want to make use of a certain service. We have the virtual devices. We'll need the software development kit comes with a virtual device, because remember, unlike with the application that you are creating in a computer, those one you could be able to create them and run on a computer. But in this case, we expect that the programs that you are creating in Android, they're supposed to run on a mobile phone. So for you to be able to test your application, you either must have a physical device or a virtual device. A virtual device is just a software that tries to mimic the operation of an hardware device. Okay. Yeah, I think I will show you an example of a virtual device on my phone, maybe on my computer. Maybe I think I can show you. Just try to open it. Yeah, so as my virtual device starts, you also have documentation. So as a developer, if you want any documentation, any instruction about Android as a whole, you just need to go to this website. You go to developers.android.com. Okay, maybe you can. I'm going to try and see how the site looks. So if you go to developers.android.com, this is what you are going to see. So this is how the developers.android.com website looks like. It has a lot of things. It has tabs here. For example, here you can see we have the platform, the Android Studio. Okay, so for the platform is for the SDK tools. You can be able to get the SDK tools from that tab. We have the Android Studio. You want to download Android Studio, click on this tab. You get the Android Studio here. You have the Google Play. Okay, you can launch the Google Play console here when you want to publish. When you want to publish your mobile application, you can see that they are saying that we have more than 2 billion active Android devices. Okay, so if you want to publish your application to these very many devices, you can be able to access it from here. But remember, like we said, for the developer account on Android, you'll need to pay. You need to pay 2,500 only. That's a lifetime, for a lifetime. Then if you want maybe something like Kotlin, you want to learn about the Kotlin language itself, can do it here, can get it here. Then we also have the documentations. Okay. So for the documentation, it tells you everything you need to know from how Android is developed. Also, it has different levels. Okay, it has guides for different levels of programmers, whether it's a beginner. Okay, if you are advanced enough, can be able to learn here. Can be able to learn here. We have courses that you can take from the online training. Okay, yeah. You also have news, any news about, for example, they are saying Android 11, Android 10. Is it 10 or 11? You can be able to view the Android 11 is already out the beta version. Yeah, the beta version is for developers, not for the end users. The beta version is already out. You can always preview it. You can get the news from here. Okay, yeah. So I think we should also have some communities here that you can be able to join. Thanks, Brian. I've resumed the recording. So that's my virtual device. So that one comes as part of the software development kit. Okay, so that you can be able to test your application even without having a physical devices. Brian, there are no any special requirements for the virtual device. Okay, because when you install Android Studio, it also gives you a chance or an option to install a virtual device of your choice. Whether I want to install a Samsung S10, can be able to install a Samsung S10, but most of them are those ones, the virtual devices for the phones developed by Google, such as Google Nexus and Oracle. But now for those whose machines have a very low maybe features, they have the below minimum, you might not be able to use the virtual device very well. Okay. So in that case, just give me a second. Try to pick a call. Hello. Good afternoon. I think we can continue. I hope I can still be heard. So like I was saying, if your laptop has below the minimum requirements, you might not need to use a virtual device. If you have your smartphone, you can always test your applications on the smartphone, on the real device. So like I told you last week, Android Studio is the official IDE for developing Android applications. Okay, and it gives you a very nice environment with everything that you need. Okay, with only one interface, you'll be able to do all the things you need instead of switching from one application to the other. Once you install the IDE, it will give you most of the things you need, whether you want to develop, to run, to remove the errors, to test, to package. Yeah. I think we have mentioned about Google Play Store. Android platform architecture, I think we discussed that. Also discussed about Android runtime or the Dalvik virtual machine. So then we have the API levels. We have API levels. As a developer, you'll need to know which level of API. Remember, like we said, the API is supposed to connect. okay, 2 programs, okay. And for your program, for your application that you create, the number of devices that you will be able to develop it, will be able to install it, will be depending on the API level that you will be using. Now you cannot create your application with C or C++. Like I said, the ones who develop with C or C++ are the ones who are developing at the second layer in the Android software, the second layer after the kernel. Okay? Those who are creating high-level libraries or frameworks, such as the graphics framework, such as the service manager, such as the SSL. If you want to develop at that level, then you'll make use of C or C++. But if you're creating your application for the topmost layer, the application that will be installed by the end users, or the application that you'll publish on the Play Store, you'll need to make use of Java or Kotlin. Either use Java or Kotlin. Those are the 2 languages you can be able to use. Okay, yeah. Though there is also a possibility where you can convert maybe code written in JavaScript, you can convert it maybe to the Java code. So then I was talking about API level. Okay, so like for example, maybe some of you have ever tried to access an application on Play Store. Then it tells you this application cannot be installed on this device. Okay, so now this one depends on the API, that the developer used. Okay, yeah. So if I use API 16, it means the only device that can be able to use that application must be API 16 and above. Okay, yeah. The APIs have a name and versions. Okay, all the names of the APIs are names of desserts. Okay, desserts, ama chakula you eat after the main dish. Okay, for example, you have honeycomb, you have ice cream sandwich, you have jelly beans, you have Kit Kats, lollipops. Okay, and you'll find that the code names of these APIs always follow each other in alphabetical order. For example, you see from H, you're going to I, J, K, L. Right now we have we are at which is the code name of the latest Android version. Maybe someone can help us. Android 10, which is the code name? Yeah, Brian, I think I've mentioned that for you to be able to create a developer account on Play Store, you'll need to pay some subscription fee. And it's only $25 for a lifetime. Then you will be able to deploy your applications for free, completely free to deploy your application, even when you want to sell them. Kennedy, you have a question? So which is the code name of the latest Android version? That is Android 10. Remember, I've said the code names of all these APIs are desserts, the foods that you eat after your main dish. So here I've only listed up to Lollipop, which is Android 5. So after Lollipop, you add L. After L, we have M. We have Marshmallow, which was Android 6, Marshmallow. We had then 7, which is Nougat. Then we had 8, which was Oreo. Then we had 9, which was P, which starts with P, that is Pi. So what about Android 10? So I think for Android 10, it's the only thing we know that it's supposed to start with Q. Supposed to start with Q, but I'm not yet know what we are yet to know what the desert name. The desert name of that Android 10. The only thing we know that it's supposed to start with a Q. Android Q, yeah. Someone is saying it's Android Q, yeah. But we expected a desert, just like the others. Same way we had jelly beans. We expected even a Q to be a desert, but currently I think it's just Android Q. But let's hope we'll be able to get a name. But like I was saying, as a developer, what you'll be looking at mostly is the API levels. Okay, so if you develop your application using API 21 or 22, that means the devices that will be able to run your application must be at least Android 5 and above. And 0, according to Android 10, will not be named with a desert name. Okay, thanks for that update. I think maybe they lacked a desert that starts with Q. So you can settle for that. So for Android 10, it will just be Android Q. It will just be Android Q. So now if you want to support more devices for your application, at least target from Android 5 and above. I think nowadays the devices that we have in the market, almost all of them have at least a Lollipop. Then we can look at challenges of Android. One of the challenges with the developing for Android application is you expect that your app will be accessed by different screen sizes. So Vincent is asking whether it's possible to lower the compatibility of an app to make it easier to be stored in a lower API. Now it depends with the developer. Okay, you as the developer, you'll go to the market and check which the devices that are in the market. The biggest percentage, it's starting from which API. So for example, like currently I think we have more than 80% of devices with Android 5 and above. Okay, so that means you can use Android 5 as your API. You can use API 21 to develop your applications. But the problem is the higher the API, the more the capabilities. So maybe you might, just for performance sake, you might need to sacrifice some devices. Yeah, can decide since my app requires a lot of this and that, you'll use a higher level API. So we are talking about challenges, and one of the challenges is maybe my device has 6 inches. We have devices with even up to 10 inches. We have devices with 10 inches. We have other devices with even 4 inches. Okay. Yeah, so you'll find that your application might look different in those screen sizes. Okay. Yeah, so that's one of the challenge. Okay, because you need a look that is universal, but the problem is the screen sizes might display your app differently than the performance. Okay. Yeah, so you need to make your apps responsive and smooth, okay, regardless of the low resources in a mobile phone. Then security, you also need to know how to keep your source code secure so that your application don't get hacked. Okay, because remember you have application which do very crucial jobs. Okay, for example, maybe let's say the loan apps like Tala. Yeah, if a hacker could be able to hack that application and clear all the loans from everyone, it will be a very big loss to that company. Also, if you try to consider something like banking applications, the banking application must be secure enough. Otherwise, someone might steal your money. Okay, yeah. So that's why you'll find that currently not so many companies have a mobile app because of that challenge of security. Okay, but if you can be able to, but now that also is also an opportunity to you as a developer. Yeah, so long as you can prove your app is secure enough, you get to earn a lot of money. Okay, yeah. Then compatibility that's now according to the platforms. Okay, you want your application to run on a lower platform, but then you want your application also to have a good performance. Okay, so that makes it a little bit challenging for you. You're wondering now, do I go for a higher API or a lower API? Then marketing, and marketing now it's about making people know about your application. For example, let's say there is an application maybe I'm working on. Okay, there is an application I'm working on with some guys, and that's one of the things that we have found as to be our biggest challenge. How do we get people to know about our application? Okay, yeah, because I think the application is all about connecting skilled people with people who need the skills. For example, maybe I might need a plumber around my area. Okay, yeah, we were looking to creating such an application that can be able to go to that application and be able to get allocation-based results. Okay, but the problem with that now, as long as it could maybe a good idea is how do we now get the people to know that app and start using it? So marketing can be expensive sometimes. Then the application building blocks. You have the resources, and the resources we have layouts, images, strings, colors, etc. You have the components such as activities, services, and helper classes. You have the manifest. And this is the information about app for the runtime. You also need the Gradle configuration files, but we'll see that with an application that you have already created, so that you can be able to see the different blocks that you'll have in the application that you'll create. Okay, but basically this is your application will consist of resources, components, manifest, and build configurations. And so that marks the end of our presentation on introduction and the architecture. To look at different things. I think I've looked at the components here. You can see this is how now the regular application looks like. You have the manifest, you have the Java folder, you have the resources, and the resources I've said is where you include the layouts, the strings, the colors, the images, and what have you. And you have the Gradle scripts. Okay, so yeah, the Gradle, basically what the Gradle does is, for those who have been programming, you know that you always need a compiler. Okay? So for mobile apps, Gradle is our compiler, one which will be converting now your application to bytecodes. So Android manifest, like I've said, the Android manifest is supposed to contain metadata, information about your application. It will tell us something like which API level you are using, which is the first activity that will be launched when your application is ran. Yeah, things like that. Yeah, Brian is asking that sometimes Gradle has problems. How do you fix that? Yeah, one thing you'll understand that Gradle usually by default, it's supposed to run while the internet is running. Okay, so the reason why Gradle requires internet is so that if it finds any framework that is missing or any tool that is missing in your application, it can automatically download it. Okay, but if you have a situation where maybe you are only running your application offline, there is an option for enabling Gradle to run in offline mode, such that even if it finds a missing tool in your or a missing resource in your application, it will not attempt to download it. So the reason why you usually run into problems is because of that. Your application has some missing resources. And now since you are offline, Gradle is trying to download them, but it can't get them. So by the end of the day, your application will not be compiled. Yeah, I think we already have a suggestion from Jero there. Yeah, you run it in offline mode. Yeah, I think that one might help. If you don't have internet connection, you can toggle it to offline mode from the preferences window. So this is an example of an app. Which you are calling a currency converter. It's supposed to convert from US dollars to euros to gallons. Okay, yeah. So this is the final interface that will look like. Okay, where we have some labels here, and you also have some text fields. You have some text fields, and you have some buttons down here. Okay, yeah. So this is an example of an app that you can create. But now for that application to work, this is a code that is running in the background. For example, this is some Java code. It is supposed to provide the logic for how your application work. And then here we have the interface. Okay, so for the interfaces, we'll be using XML. Okay, what you call extra markup language. They look somehow like HTML. Like you are using tags just like HTML. Yeah. And so we'll be using XML to create our interfaces. We have then some resources there. Yeah, so now the next thing we'll be looking at is we'll be looking at the application components with a real app. But I think we'll need to need you to install the Android Studio in advance. So that you can be able to look to see how an application looks like. when you install one, I mean when you create an application, which files are involved. So I think before we look at the application components themselves, I would want us to look at how you install the Android Studio. So for those who have not installed Android Studio, I will need you to go to this site. I will need you to go to developer.android.com and click on download Android Studio, say 756 MB. 756 MB. If it's possible, you can install it when you are connected to the internet, so that if there is any additional component that is required, you'll be able to download it and install. Okay. But basically what you'll need is you'll need the Android Studio, the IDE. You'll also need the SDK, that is software development kit, and you will also need a virtual device. So Brian, it's not a must you install the emulator, especially if your machine is not good enough. I would recommend you don't install an emulator. So now, how can you test your application directly on your, with using your smartphone, that very good smartphone that you have? One thing you'll need to do is you need to enable USB debugging. You'll go to settings and you'll see developer options. Let me see whether I can be able to demonstrate that with my virtual device here. This is my virtual device. So you need to go to settings. If you can't see developer options from your settings, you'll need to go to about phone. I don't know whether my device is visible. You can see it's still not very smooth. Just a second. I don't know whether you would want me to take you through installing Android Studio. Go about it. like I said, if you can't be able to see developer options on your phone, you go to about phone, and then you'll see there is the build number somewhere. Then you tap on it 5 times. You tap on it 5 times, you'll see that you are now, you tap on it 5 times continuously so that you can be able to see the developer options. So for example, I've tapped my build number 5 times. So now if I go back to the settings, I think I should be able to find together, I can be able to find the developer options. I think I'll pause the recording for a while. Here it is. It's visible. To zoom in. In my case, USB debugging is already on. I just need to make sure that USB debugging is on. Yeah, it's visible enough. So in my case, it's already on. That means if I click here, it will be off and I'll not be able to install applications directly from my Android Studio. Okay. So when you do that, every time you connect your device with a USB cable to your machine, maybe it will give you a prompt like this one. It will give you such a prompt. Allow USB debugging, and then you click OK. Okay. You can always check on the remember. This always connect on, always enable on this device every time. But now these ones will, the settings basically will depend with which Android version you're using on your mobile phone. So for installing Android Studio, I think I'll show you how you go about installing Android Studio. That maybe when we meet next time, you should be able to. You should come with your Android Studio ready. So now I've said the first thing you do is you download the setup file from developer.android.com. You go to that website, you download the Android Studio, then you open it. Remember, like I've said, if it's possible, install it with your when you're connected to the internet. Yeah. Then you open it. After the installation, there is nothing you need to change there. You just click next. You use the standard mode. Then as soon as as soon as you have the installation is complete, it will bring up something like this one. Make sure you install the latest version 3.6. Install version 3.6, so that will be on the same page. You'll see something like this. So you have a successfully installed. Okay. So after installation, the first thing you'll need to do is you also need, for those who want to use a virtual device, you need to click on configure, select Android Virtual Device Manager, AVD Manager. For example, you can see myself, I've already installed one device, but I can create another one. So there is a number of devices that you can choose from. Most of them are the ones from Google. Maybe I could select something like, let's say selected Pixel XL, extra large. Okay. Then I'll click on next. And from there, you'll need to choose the API that will be installed in your your virtual device. For example, let's say I selected Oreo. It's going to download around 1 GB. Going to download around 1 GB. I think for my internet it's good. It can be able to download in the next 2 minutes. But actually you'll be able to, after that you'll be able to give it a device name, and that's all. Most probably I can, okay, let me see. And give it just a minute to install. In the meantime, you can ask any question you might need to concerning the, but remember, okay, for you to be able to install the virtual device on your machine, your machine should be able to support virtualization, and the virtualization must be enabled. To enable virtualization, you go to, you enable that from the BIOS settings. That's why you enable virtualization from BIOS. Do you like maybe me to show you how you enable virtualization in BIOS? I think I can show you that. Let me, that's my, I don't know whether this one might take, I think it's almost finishing installing my virtual device that I have selected. So for that, I'll need to restart my machine. So I will use my phone camera to show you how you go about enabling virtualization from the BIOS. I think most of the machines that have come recently, unless your machine is very old, most of them support virtualization, even desktop. So I can see Brian talking about hardware acceleration. So for you to be able to use that virtual device, also you must enable Intel hardware acceleration. That one you just need to install the driver for hardware acceleration. As you wait for that, I want you to note that I created a forum for this unit. When you go to your course page, you see the forum. You can always discuss some things there concerning, and if you want to add any topic, you can add a topic there and your members can contribute, or maybe you have a problem you want the rest of the class to help you, you can always use the forum, the unit forum. I think I posted a question there. Please make sure you can maybe contribute to it. Times are usually marked. You have some points. Contribute. After it's installed, I'll click on finish. Then I'll go next. You give it a name. I can leave that name as it is. Then I click on finish. Now you will find that I have two virtual devices. Install two virtual devices on machine. It can be visible from your end. I have two virtual devices there. You can always run in any of them. Run any of them. But maybe it will not work for, but it's always worth a try. Just check from your BIOS settings whether there is virtualization. I think I can show you how you do that. But for that, for me to show you how you test it in BIOS, I need to restart my machine. For example, maybe I already have one virtual device running. Maybe I can decide to open my new one. So depending on your machine, you'll need to press a certain key when your machine is starting. So I think I'm going to restart my machine now. Okay, I think this one might take time because I think you can see there are some updates that are supposed to install. They can try, let me see. So before my machine starts, I'm going to press on F2 for Dell. As soon as the screen comes on, I'll press on F2. It will take me to BIOS. So you can see down here, there is virtualization support. In your BIOS settings, you will find the virtualization. Okay, I just need to enable that here. See, for example, mine is already enabled. So the only thing you needed to know is when you restart your machine, as soon as you see some lights on the screen, you press on the key for entering BIOS. For Dell, you use F2 to get to BIOS. For HP, you use escape. So as soon as you see some light on the screen, place escape. Okay, some prefer pressing escape continuously when your machine is booting. And but the interface might look different. It might look different on your end. There are some which might have some tabs on top here. It have some tabs that you can switch between. But when you navigate, especially whether it's advanced setting, if virtualization cannot be visible from the top level menu, you can check the advanced settings or something. But if you switch between the settings, you will be able to see where you enable virtualization, just make sure it's enabled here. For example, mine is enabled. If I wanted to disable it, I'll disable it. But if I disable it, that means I will not be able to install a virtual device or run one. I hope we are together on that, on how you enable virtualization in your machine. I think I can exit this one. You have understood on how to enable virtualization in your machine. Anyone with a question concerning that? So then after now you have installed the Android Studio, how do you create an app on Android Studio? It's very easy. I think I'm going to show you from my screen. So when after you have installed your Android Studio and you have your SDKs installed, you have your virtual device already installed, just need to click on Start a new Android Studio project. And it's going to show such a screen. There are some templates that are already there for you. There are some templates that you can choose from. You can choose maybe a full screen activity. So for the templates, they come with some code already installed, but I wouldn't want you to go that way because that one gives so much code that you don't need. So the best way to do is you start based an empty activity. You click on empty activity, so that one will give you a fully completely empty slate for you to start creating your applications. Then after selecting the empty activity, you just need to click on next. Then you can give your application a name. For example, hello, call it hello. app. Then you can give the organization, you can use the organization name here, but you can leave it as it is. Then here you need to choose the language. Okay, you can either go for Kotlin or Java. Okay? Yeah, like I said, Kotlin is the best because it actually reduces your code by up to 50%. And the good thing about Kotlin is it's able to interoperate with Java. That means if you have, you can put Java code inside Kotlin and it will still work correctly. So let's say, for example, we just go for Java. Okay? Then here is where you choose the minimum API or the minimum SDK. Currently, we have selected Android 4.1, and then even Google is telling you here, approximately 99.8 of devices will be able to install your application. If you go to maybe Lollipop, only 94% of all the devices will be able to install your app. If you go to maybe the latest Android R, less than 1%. If you go to Android 9, you'll find that 39% of the devices will be able to install your application. Let's say we go for the one with the 100%. Let's even use that. I think we can always go for 5.0 API 21. Then you click on finish. So now, and it will open up these very well created IDE. Close the tips. Okay, so you'll find that it'll by default the IDE will create some files for you. Okay, and those some of the two files that will be created by default are one service, which is main.java, and the layout activity main.xml, which is a screen. I think it's an interface actually. But if you go back to your app, back to the app. So before you open that, these are the folders that you'll find in your these are the two folders that you find in the application that will be created. You find these two files. So for the Grando scripts, those are just the files for compiling. Files for compiling your application. Remember, this is a project manager window. Remember, you have different windows, most of which are already pinned. For example, you have the resource manager, you have the project, you have the favorites window, you have the build variants, you have the structure. You can see also you can be able to view the terminal from here. You have the build window. You can have the log cut for logging. That one shows what is happening when your application is running. You have the things to be done. We have the Grando here, Grando window. You have the device explorer. Yeah. So you find that the Android Studio is composed of just a number of windows, but initially the windows are usually minimized. Okay, only the window that you are working on will be. So you can always do that. You can minimize most of them. So this is where you are. This is where you are now as a developer. Okay, you have two folders, two main folders. I've said the Gradle scripts. Those ones you don't need to. You should not tamper with them. You should not touch them. Then we have the app. For the app, it has three. It has three folders inside there. We have the manifests. We said for the manifest, what it has is the information about your application. Okay, here's the information about application. It tells you which is the main activity, package name. Maybe if you wanted to change the package name, you can come and change it here. Allow backup and things like that. So this one contains the information about the app. Then you have the Java. This is where your Java files will reside. For example, I only have one class in my Java files, which is this one, which is the main activity. I think let me just close these ones. Inside your Java folder, these ones are just for testing. The two extra folders are only for testing. The one that you're working on is the first one. If I open our main activity, it doesn't have a lot of code. Just some Java code inside it. Then that one will be containing only purely Java code. The Java folder will only be containing Java code. If I minimize that, I go to the resources. So for the resources, it has the layouts, the values, drawable. Okay. So if, for example, if I go to the layout now is the one which contains your screens. The one which contains your screens or what you are calling the activities. Remember, we said your application is made up of screens. Even your lock screen is an activity. So all the activities will be inside this folder. So if I wanted to add an extra screen in my app, I would save it in the layout folder. So for the values, this one contains strings, colors, and styles. Styles, you need to include some CSS inside there. You can try to open there. Remember, like I said, for the interfaces, using XML. So you have some the activity main here. When you open it, you'll see there just tags. Look like start with an anchor bracket and end with another anchor bracket. So this means this is one component. Means that one is just a single component there. So if I wanted to add another component here, I can add it down here. Okay, for example, let's say I wanted to add another text view. I can add it below here. I can even use the suggestion that it's telling me. For the width, wrap, can choose maybe something like wrap content. Okay. In this case, this is another component that I have added. In my application. Remember, for your interfaces, you can be able to switch between the different modes here. For example, this is the code view. I can switch to design view. If I switch to design view, I'll be able to drag and drop. I'll be able to drag and drop components. For example, if I wanted a password input, I just need to click and place it in my workspace. If I wanted maybe a number, just need to drag and drop it here. That's a good thing about Android Studio. You can be able to create and you can be able to see that as I continue dropping my components, even my code is growing. Okay? So that's a good thing about it. Then we also now have another name. This one, it will help you see how your application exactly will look like before you even run it. For example, now if I wanted to run my application, Just remove this extra. I wanted to run my application, I just need to click on this button here. Someone is asking about the blue windows. The white one, it allows you, it shows you the position, the exact position, but you can always have only one of the view. You don't have to have the two of them. You can actually even add another one. But in real sense, they actually the same, they perform the same thing. They're just giving you different background. Actually, there isn't shouldn't be any difference between the two of them. It's just giving you a different background. If I want to run my application, I just need to choose where do I want to run it. Either choose one of my two virtual devices. Let's say I use this one. Then I click on run button. Open up my emulator. Open the emulator and install the application. I think I can switch to my emulator. Seeing zeros saying that the blue one is to show how the app will look like and white is used for configurations. I don't think so. Actually showing the same thing. Just the difference is just background. There are some who like white background. There are those who like those ones for the dark ones like us. If you want to see how the app will appear, I think there's an icon for switching. The browser is retrieving my windows. My emulator is taking time to load. As my emulator loads, maybe someone with a question can ask concerning installing Android Studio. Can you be able to start? Can you be able now to install a studio and be able to start an application and start a new application? So if you all understand, I would expect you maybe by our next class you'll have installed the IDE, and at least make sure you are either you have a virtual device or your phone is already configured to be able to test your application. So what you can do is just to test around, you can try creating an app, an interface that looks like the one that is in the notes. It will be like an assignment, and try install Android Studio and install and try to create an interface just using the drag and drop. Create an interface that looks like the one that is in the notes, but avoid don't do the Java part. Avoid the Java code. It might not might give you some headache for now. We look at it later. That next time in our next lesson we'll be looking at Android application components. We'll be looking at application components. No one with a question? If you don't have a question, maybe I can ask someone to tell us what some of the challenges that you're likely to face when developing mobile application. What are the challenges you're likely to face when developing Android applications? Some of my students haven't said a thing. Maybe Maureen can tell us some of the challenges that you're likely to face. Then Philip can give us some of the hardware components in an Android phone. Then Grace Musioka can give us some examples of software components. Then Inywa Perpetual can give us the different layers in an Android software, the different layers in Android software. Then Maureen, you have to give us hardware components. Yeah, hardware components. I think Philip has already given us hardware components. So someone was to give us the Grace Musioka. I can see you have told us about SQLite capability, graphic capabilities. Those are the hardware components. Then and Maureen, maybe you can give us some of the layers, that are there in Android software. Senior Perpetual, Maureen, and Kate can give us some layers in an Android software. still waiting on Kenya Perpetual and Kate. I can see Perpetual have given us Linux kernel, libraries, Android runtime, application framework. Yeah, that's correct. Then can have Ichuki telling us which mobile operating systems are still there in the market. Which mobile operating system are still there in the market? Ichuki. As which operating system, mobile operating system there are there in the market, and why did we think we chose Android to work with Android? Then we can have Wamboi telling us some of the tools that are available in the software development kits. Tools in SDK. Wamboi to tell us the tools in SDK. Then Brian, you can tell us, Brian or Pio, you can tell us what an AVD is. Tell us what an AVD is and why you would need it. You can see Kay that told us about application framework layer. So application framework layer, what are the components? What you can mention maybe one of the components in application framework layer in Suko K. Brian, I want you to tell us what an AVD is and why you would need it when developing your mobile application. So for Wambui, I've asked you to, what was the question for Wambui? I think I've asked quite a number of questions. I even forgot which one was Wambui. Let me try to check another question that maybe you can remind us on. Oh yeah, I think Wambui asked you about the components of the SDK, Software Development Kit. What are some of the components of Software Development Kit? Components of Software Development Kit of the SDK. Can we just talk about? They want you to tell us what some of the frameworks, some of the libraries that are there in the application framework layer. Brian, I asked you to tell us what an AVD is and why you would need it. We're developing Wambui, that's true. You have the debuggers, compilers, and code editors. You have virtual device AVDs, and what have you. Yeah, Gichuki, you have mentioned Android, iOS, and Windows. That's true. We also have BlackBerry, which is likely to end by the end of this year. They have said by the end of this year it will be out of they will end the support. So Brian, you have said an AVD is an hardware simulation for Android emulators, and we need it to debug and test our apps. Actually, don't use it to debug. For debugging, we'll use your debugger. You'll use the debugger, which is available in Android Studio. So you'll only use it to test our apps when we don't have an actual device. When you don't have an actual device, it's true. Then I think Patrick hasn't answered any question. Patrick, you can tell us what you have learned in the lesson. Let's see, Patrick. Patrick, are you still around? What have you learned during the lesson? What was the main thing that you have learned? Together with Vincent and Komora. Then a general question. I don't know how many of you in the class will not be able to acquire personal computer. Anyone maybe you might not be able to acquire a personal computer for this class, and maybe you can tell us how you'll be able to follow our audio. Yeah. See, our time is almost gone. And it's also lunchtime. Maybe we can have 3 minutes for anyone to ask a question. Then we call it a day. Patrick has learned the components of Android devices, such as Dalvik virtual machine, building our blocks. It's very nice. One with maybe a question. So remember, you have said for our next class, supposed to have installed the Android Studio and create a simple application. You can use the interface that I've shared in the notes. You can try to create such an interface so that we'll be able to see the challenges we'll have faced during our next class. If you have any problem while installing Android Studio, feel free to contact me. You can always on WhatsApp, you can send me an email, you can send a text message, or even when you want to talk, you can also request me to call you. I might not call. So if you encounter any problem, feel free to. Mira hasn't talked today. Kennedy, I think Kennedy talked. Kennedy was actually even to share his background. So make sure you're able to install Android Studio before the next class and create a sample application. Then we'll be able to discuss the challenges that maybe you might have faced. If you have any problem, feel free to talk to me about it. I think with that, maybe we can end the meeting if you all agree. We'll call it a day now. Brian, Patrick, Okay, I think no one is against the idea, so I think we'll end the meeting. I wish you all a nice lunch. Stay safe. Okay, don't ignore cleaning your hands. We'll meet again next week. Have a nice weekend.